Welcome to DCC. This is a question number C of latest Codeforces round 890, and this is the solution. Okay. So what is the question? You have given an array A of length n, and there is one operation. In one operation, you can choose an index I such that I is 1 to n minus 1 according to one based indexing, and with the condition that AI is less than equal to AI plus 1. This is very important condition, point to be noted. And you can increase AI by 1. Okay. So yeah, this is the operation. And what you have to find the maximum possible value of max of a1 comma a2. So you have to find the maximum element in the array. Okay, after performing operations that you can get after performing this operation at most k times. So you can perform at most k times. Okay, not more than k. Okay. So how you will do this question? So if you will think some greedy solution, it won't work because like I have thought that choose the maximum element, like these are the positioning of the maximum elements, say let's suppose x here and x here, and we can do this, we can apply this operation here, and we can make this number x plus 1 and do again this like this like this. So it will not work. So it is not a greedy solution. You can apply, then you will realize that it will not work like here. Let's take 65415. So this is our maximum element, but we can make the element 7 here. How? That make this element 5, then make this element 5, okay, then make this 6 and then make this 7. So here total 6 operation will work, okay. So how you can think? So I am giving you one hint that use binary search here, binary search on answer, then you will get the answer. So this is the hint, you can try with your own, but if you not get it, so you can continue this video. Okay, so let's come. Okay, so what, how you can apply binary search? So what is the approach of this question? That you will you will do binary search on answer, that you will check on answer that this answer is possible or not. So means you can make the this answer, means this value, to the array or not. Okay, like you have given an array, so I will choose so here the range is very here range is n equal to 10 cube. Okay, so you can apply big O of n square solution, and binary search is log n, so you can do big O of n square log n. Okay, so one hint for binary search is here, that n is less, so you can do n square. Okay, so coming to the binary search approach, that if you can make the answer, so it will be like a monotonic function, like true, 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 false, 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 false. Okay, so you can apply in binary search. So the main game here is to how to make the function to check that it is possible or not. The main game is here only, that how you will check that this answer you can make in this array or not. So how you will do? Okay, so how you can do, like you will go to every index of the array and say that I want to make you like this element I want to make this element to the mid. Okay, so if this element AI is already is greater than equal to mid, so I will directly return 1. But if it is not, then I have to do some operation which is equal to mid minus AI. But to do here operation, we have to look at this element. Means if I want to make here operation, because there is given condition that AI should be less than equal to AI plus 1. So if I want to do here operation, I have to make this element at least to the mid minus 1, because if here it is 2 and if it is here 1, so I can make this element to 3. So if I am making this 3, so at least this element have to be 2, so that I can make this to the 3. Okay, so I hope you have get that why I am doing that. If AI should be, that I want to make AI to the mid, so this element should be greater than equal to mid minus 1. And if it is not greater than equal to mid minus 1, so my in my total operation I will add that it will be take mid minus 1 minus AI plus 1. Okay, now again if I want to make operation here, so I want to make this element at least to mid minus 2 to have this element mid minus 1. If it is already greater than equal to mid minus 2, so I will break my operation and I will count my total number of operation. Okay. But if it is also not greater than equal to mid minus 2, so I will again continue like this. So okay. So I will count the total number of operation in sum, and if sum is less than equal to k, then I will simply return true. Okay. So I hope how this working is done. And here is one more edge case, that any element if any element is not means the condition don't hit, like it is 5 4 3 2 1. Okay, and I want to make it to the 10. So here 5 operation will be here 5 operation will, if I want to make here this element to the 10, so here it will be take 5 operation. Here also it will take 5 operation. Here also 5 operation. Here also 5 operation. Here also 5 operation. But how can I make this to the 6? Because here is not any element such that ai greater than ai is less than equal to ai plus 1. So I have to make one check that one condition should hit, that some element is greater than, means some element is less than equal to ai. Okay, so see the code, then you will understand very easily. It is not a very tough question. It is like if you have practiced one binary search question, then it is very easy. Okay, yeah. So I have taken n input, that is the size of the array, and it is k, the number of operation you can do. And I have taken input in my array ai equal to x. Okay, and I have taken one maximum, that it is also be the answer, right? Okay, then I have performed my binary search, and this is my solve. This is my check function, that it will say that if this mid is possible, then I will convert low to mid. If it is not possible, then it will come to high equal to mid. Okay, so this is my main check function. This is the main game here. Okay. Okay. So what I have done, this is my n, the size of the vector, and this is my sum, denoting that the total number of operation required to make the maximum element in array A to the equal to the mid. Okay, this is my sum, and it is my x equal to mid, and it is flag equal to 0. These two will be use of later. So I have make one for loop. I will check for every element that I can make this ith element to the mid or not. Okay. If it is greater than equal to mid, then I will simply return 1. But if it is not, then I will add it to my sum, that minimum this number of operation is needed. And here x is equals to mid, so I have done x minus equal to 1 for the next operation. Means j is my next. Like this is my I and this my j. Okay, this is my j, I plus 1. Okay, so I have to make this at least to mid minus 1, and if it is already greater than equal to mid minus 1, so I will make flag equal to 1 and that will break. But if it is not, then I will directly add it to my total number of operation. Okay, and after completing one nested for loop, then I will check that if sum is less than equal to k, and then flag. This is denoting that my this condition hit. If it is not hit, then I can't do anything. So this flag denoting this. Okay, and I will returning 1. Else I will returning 0. That I can't make it to the mid. So I hope you have get the question. This is a binary search question, the advanced binary search. So yeah, thank you so much.